Vibe coding can accelerate software delivery in the right hands. The 2025 Stack Overflow survey shows widespread use, with roughly half of professionals using AI tools daily, and controlled trials point to meaningful speed-ups. But adoption without guardrails is where budgets burn and roadmaps slip. In this session, we're counting down the top 10 vibe coding mistakes that quietly undermine enterprise value, security, cost, reliability, and most importantly, trust. One of these mistakes is arguably the most crucial of all. I'll flag it when we get there. So what exactly do we mean when we say vibe coding? By vibe coding, I mean natural language driven, agent assisted development where tools can read and write code, orchestrate terminals, even raise pull requests. Think of tools like Cursor, Claude Code, GitHub Copilot, and even Gemini Code Assist. They are powerful, but their outputs are only as safe as the guardrails we set. Let's anchor these guardrails with a practical blueprint. The BrainCube Agentic AI Blueprint takes you from pilot purgatory to measurable impact. We start with strategy, map the value and the risks, then mobilize. This is governance, controls, and evaluation in place. Next, we prove value fast with a real pilot, then embed it into daily workflows. Finally, we scale responsibly with cost controls and compliance built in. Every step ties back to your P&L. Now, 10 vibe coding mistakes that risk your enterprise value, starting at the source control layer. Mistake number 1, not Git tracking. Git tracking is a system used to manage and record changes to files in a project over time. It allows multiple people to collaborate on a project by keeping track of every modification made to the code base. If an agent makes a sweeping change and you're not Git tracking, you have no audit trail, no ability to track changes, no ability to revert changes. Initialize Git immediately via GitHub, GitLab, or any other Git tracking software. Push to a remote, commit to that remote early and often. Once you're in Git, don't point agents at the main source code. This leads us on to mistake number 2, having no development branch. A development branch is a copy of the main branch, also tracked by Git. You can make changes here that do not affect the main source code. Agent making changes straight to the main source code is how you ship vulnerabilities, bugs, and incidents. Instead, do your development in branches. Merge to development branch and gate behind continuous integration and reviews. Only when you're confident in changes, you can merge these changes to the main source code. But we should keep those changes small too, which moves us on to the next mistake, shipping massive unreviewable changes. Put yourself in the shoes of one of your senior engineers who is responsible for reviewing changes to the code base. Now that every developer is equipped with AI coding assistants, they're pushing thousands of lines of code to review. This isn't sustainable. Large changes bury defects and waste reviewer time. Google's guidance on this is explicit. Favor small changes, single purpose, high signal changes that you can reason about and roll back quickly. Now, let's talk a little bit about provenance. The next mistake I see is poor commit messages from developers. Commit messages provide provenance to code-based changes. They give an overview of what was changed, why, and by who. However, the quality of these messages depends on the engineer making a commit to the code base. High-quality commit messages are no longer optional, especially with the velocity of code generation introduced by these new coding agents. Agents and humans both rely on commit history for context. Use consistent labels for your code changes, like new feature or bug fix. After making any changes to the code base, have your AI coding agent write the commit message draft. Then review it and make sure it's correct before pushing to branch. We should talk next about one of the costliest failure modes, and it's to do with secrets and API keys. Vibe coders often hard code secrets into their scripts. This is a mistake. Secret leaks are climbing. GitGuardian tracked a 28% year-on-year increase. A single cloud key can rack up compute spend or expose data. Keep secrets in a .m file locally. In production, you can inject secrets from a secret manager and enable GitHub secret scanning. You can even set up workflows to push secrets from a local .m file directly to Secrets Manager, with the correct permissions, of course. In short, never hardcode your API keys or secrets into your scripts. Let's talk about controlling what agents see in your repo. The next mistake that vibe coders make is not having ignore files for agents. From the last mistake, it should be obvious to you now that you do not want to expose your .m files or any files containing sensitive data. This is even more the case when you're using coding assistants. If your .env or dataset dumps enter the agent's context, you've created unnecessary exposure. There are special files that should be in your codebase that can tell coding agents and tracking software to ignore files containing sensitive data. One such example is the .gitignore file. Cursor respects the .gitignore and adds also a .cursorignore. If you're using Claude code, be warned that no such thing exists yet at the time of recording this video. However, Claude Code's community has asked for a dedicated .claudeignore to function the same as a .gitignore or a .cursorignore. Start every repo with a curated .gitignore and an agent-specific ignore file. The next two mistakes can also be very costly to any unsuspecting vibe coders building production applications. Let's talk about OR. Let's move on to mistake number 7. No authentication. Authentication checks who is using your system. When you don't require users to log in, bad actors can easily misuse your service, especially when automated tools make thousands of requests. Always require login credentials, change passwords, keys regularly, and limit how many requests expensive features can handle. This is a practice known as rate limiting. And remember, authentication is not the same as authorization. This leads us neatly onto mistake number 8, no authorization, or mixing it up with authentication. Many vibe coders confuse authentication with authorization. Authorization determines what actions a logged in user can perform in your application or system. OWASP, the Web Security Organization, lists broken object level authorization and function level authorization as top API security risks. Follow the principle of least privilege. Give users only the minimum permissions they need and use row-level security in Postgres to automatically restrict database records based on user permissions. Failure to enforce proper authorization controls exposes your organization data to breaches that can trigger regulatory fines in the tens of millions, class action lawsuits, and lasting reputational damage. Even if you secure your APIs though, you should plan to scale past the demo. Let's talk about mistake number 9, building applications that don't scale. Many vibe coded apps work locally and fall over as soon as you reach scale. You need to be running production readiness reviews. This might be load tests before going live, lining up auto-scaling and capacity plans. Treat cost and reliability as first-class, non-functional requirements. All of this hinges on the final and most important point here. Mistake number 10, not starting with architecture and specs. If you don't start your project with clear technical requirements, AI coding assistants will assume you're building something simple for just one person on a single computer. Instead, define these basics up front. Who will use your application? This should cover how many people and what are their roles. How many people at a single time? Will 10 people use it simultaneously or 10,000? What kind of data? Are you dealing with customer records, financial information, public content? Where must your data stay? Some countries require data to remain within their borders. How will it be deployed? Are you deploying on a single server, multiple locations, cloud platforms? What rules must you follow? Are there any industry regulations, privacy laws, or security standards? You can use Amazon's well-architected framework as a checklist for important technical requirements like security, reliability, and cost control. Start with one integrated application rather than breaking it into separate microservices until you understand exactly what each part needs to do. Write automated tests that check these requirements are being met, not just that features work. The main point, Be specific about the real-world constraints from the start, or you'll end up having to rebuild anything when you discover the requirements later anyway. Let's bring it home with a short checklist. Here's a recap. Have Git set up from day one. Set up version control with a cloud backup immediately. Don't wait. Curate.gitignore and agent ignores. Maintain lists of files to exclude from version control and AI assistance. Secrets in managers with scanning. Store password keys in dedicated tools. Scan code to prevent accidental exposure. Feature branches and small changes. Work on separate code branches for new features. Keep changes small. Authentication everywhere. Authorization by least privilege with row-level security. Require authentication throughout the system. Limit user permissions to minimum needed. Enforce restrictions at the database row level. PRR, load tests, and written architecture with data flow. Complete production readiness reviews. Test system performance under load. Document your system design, including how data moves through it. The core message: implement proper development practices, security controls, and documentation from the beginning rather than retrofitting them later. Vibe coding multiplies skill teams if you set guardrails first. Invest in architecture, security, and review hygiene, and you'll keep the speed without the burn. If you want a low-risk start, book your scoping call today with BrainCube. Thank you.